Today we're going to do section 3.6, the chain rule. Let's look at example 1. Consider the function f of x equals 2x squared minus 3 all squared. How could you compute the derivative? Well, first we would have to rewrite 2x squared minus 3 all squared as a product of two factors. So we'd have f of x equals 2x squared minus 3 times 2x squared minus 3. Then from there, to find the derivative, we could just use the product rule. So f prime of x would be 2x squared minus 3 times 4x plus 2x squared minus 3 times 4x. And you would be done. Well, today we're going to introduce the chain rule, which can help you take the derivative faster so that you wouldn't have to distribute through and add like terms. So the chain rule. If f is a differentiable at a point u, which equals some function g of x, and g is differentiable at x, then the composite function f on g of x equals f of g of x is differentiable. Therefore, it would be f prime of g of x times g prime of x. So the part that we really stress for you to remember is this part here. We don't normally see compositions written like this. We see it more written like this. In Leibniz notation, you have dy dx, our function, equals the derivative of y with respect to u times the derivative of u with respect to x, and you'd plug u back in. And we'll see how to do both of these ways in the next example. So example 2, find the derivative of f of x equals 2x squared minus 3 all squared using the chain rule. So we're going to use the chain rule two different ways. So the first way is we're going to use the f of g of x function that we had before. So looking at this, our f of x, the inside function, is, or our f of x, the outside function, is x squared. Therefore, f prime of x would be 2x. And our g of x function, the inside function, is 2x squared minus 3. So g prime of x would be 4x. Okay, in order to find our original derivative using the formula, because if we go back and look, we're using this formula here where we have f of g of x. So we have our outside function and our inside function. Our outside function was the x squared. Inside function was g of x. So when you have a function like f of g of x, to find the derivative of that, that would be f prime of g of x times g prime of x, when I want to find the derivative with respect to x. So we would just go ahead and plug in. So my final derivative for that original function up there, using this formula, would be 2 times 2x squared minus 3 times 4x, or just 8x times 2x squared minus 3. Another way we can do this is we can have y being u squared and then u being 2x squared minus 3. So therefore, if I find dy over dx, it's the derivative of y, which would be 2u, times the derivative of u, which would be 4x. And then I have to go ahead and plug back in what u is. So it'd be 2 times 2x squared minus 3 times 4x, which again simplifies to 8x times 2x squared minus 3. The outside-inside rule. It sometimes helps to think of the chain rule this way. If you have y equals f of g of x, then dy dx equals f prime of g of x times g prime of x. In other words, differentiate the outside function f and evaluate it at the inside function g of x, left alone. Then multiply by the derivative of the inside function. And the power chain rule. If f is a differentiable function of u and u is a differentiable function of x, then substitute in y equals f of u into the chain rule formula leads to this formula. The derivative of f of u is f prime of u times the derivative of u with respect to x. If f of u equals u to the n, then we get the power chain rule. And the power chain rule is you multiply, so we have the derivative of u to some power. So it's the derivative of the outside times the derivative of the inside, or just you take and use the power rule like you normally would. Subtract 1, multiply by the original exponent, subtract 1 from the exponent times the derivative of the inside. Derivative formulas with the chain rule. So if I'm taking the derivative of sine u, meaning u is some function like x squared, it would just be cosine of x squared times 2x. And the same thing with cosine u, it would still be negative sine u, but then times the derivative of what u is. Tangent u would still be secant squared u times the derivative of whatever u was. Cosecant u, the derivative of that would be negative cosecant u cotangent u times the derivative of whatever u was. And the derivative of secant u would be secant u times tangent u times the derivative of whatever u was. So you have that chain you have to add on at the end. And then the derivative of cotangent u would be negative cosecant u du dx. Differentiate cosine 3x to the fourth minus 2 with respect to x. So I need to take the derivative of that. So the derivative of cosine 3x to the fourth minus 2. So it would be the derivative of the outside. We know the derivative of cosine is negative sine, so it'd be negative sine of 3x to the fourth minus 2, which is my u, times the derivative of that 3x to the fourth minus 2. So times 12x cubed. And you can leave it like that, or have your negative 12x cubed times sine of 3x to the fourth minus 2. Example 4, more composite functions. An object moves along the x-axis so that the position function at any given time t greater than or equal to 0 is given by s of t equals sine of 5t minus 3. Find the velocity of the object as a function of t. Well, we know our velocity function is the derivative of our position function. So we just need to find the derivative of sine of 5t minus 3. So that would be the derivative of sine is cosine, so cosine of 5t minus 3 times the derivative of 5t minus 3, which is just 5. So simplified, we move that coefficient to the front. It would be 5 cosine 5t minus 3. Example 5, repeated use of the chain rule. So you can use this repeatedly. Find the derivative of y equals the cube root of sine x squared. Sometimes the chain rule needs to be used more than once to find the derivative. And ETA stands for evaluate, then trigonometry, then the argument. Okay, so I have here y equals the cube root of sine of x squared. Well, we all know that we can rewrite the cube root as sine of x squared to the 1/3 power. So if I want to find y prime, that 1/3 power comes to the front. It would be sine of x squared to the negative 2/3 power times the derivative of sine of x squared, which is cosine of x squared, times the derivative of x squared, which is 2x. And you can just leave it like that. If you really wanted to, you could simplify, but you could leave it like that.